as we are having the recorded thing available, those who are absent can also watch it. Those who want to understand once again can also watch it. Now, the theme is regulated DC power supply. Now we will address the issue step by step. Suppose if now you bring, listen very carefully, each and everything I will try to be as simple as possible. I will try to speak in English for majority of the time, but few things wherever we need to explain in more deep, I may be using Marathi language so that, but I am sure that the Marathi understanding index of non-Marathi people is much more than English understanding index of normal people. So there should not be any issue. So now, if we bring, I will ensure the speed appropriately so that comfort and peace is optimized. Anyway, suppose nowadays the world is of miniaturized battery cells. You might have even forgotten about a torch which used to have AA cells, or rather there was a time of standard cell. Now nobody uses standard dry cell, which if you ask your older generation, your parents, battery cell was a peculiar name of that and standard size. But now there are normally say AA and very small is AAA in remote and all that, you may be using it, right? Now I would like to ask a simple question. Suppose that there is a, now torch is not needed because in your mobile you are having an LED lamp, you can get a torch. But earlier days, let us say that a torch is there, it is containing 2 battery cells. What is the nominal voltage of battery cell? Voltage of battery cell? The battery cell which you bring from market, what is the rated voltage of it? 5 volts. You are a student of electrical engineering. Battery cell, how much rated voltage? Nobody. 12. No. Not that small, that is button-like cells, conventional cell, small, AA cell or AAA. Kitty? 110. Anyway, not knowing it can be a fault of your generation because you have not yet used to it to a large extent. It is 1.5 volts. 1.5 volts. Now, you use the battery, you bring 2 cells, put in the battery, use it for exhaustive time, and after some time, it gets dried out. ज्याला मराठीत सेल जळले म्हणतो, घरी विचारलं असेल तुमच्या नेक्स्ट जनरेशन सेल जळलेले. So the cell is exhausted. Suppose if you are a student in engineering college and bring those cells, and somehow there is, I don't know whether such kind of curiosity is again peculiar of your generation or not, and just bring the cells to the college, the laboratory to take some readings if you feel so. That anyway, that now till yesterday the battery was working, now it has stopped working. So let us see what has happened to the cells, and you bring the cells. And also what has happened that when you are coming from home, you are told that you bring 2 new cells as the cells have exhausted. Then what do? You purchase new cells. Also old cells you have collected and brought it out of curiosity, and you come in the lab with 1 or 2 new cells, brand new cells, and 1 or 2 exhausted cells. म्हणजे 2 जळलेले आणि 2 नवीन असे सेल घेऊन आपण आलो. And we start conducting an experiment, a simple experiment which does not require any other instrument than the cell and one more instrument, that is the voltmeter. Nowadays it is DVM. And now it's a very interesting question, and I am sure that most of you would not be the question to answer. This is a cell, right? Now you have a digital voltmeter, DVM. Have you used it to take readings? Yes or no? No. Then if you take this DVM and connect it to two ends of a cell, which is a brand new cell, brand new, what would be the reading of DVM? 1.5 volt. This is a question which obviously everybody will answer, because there is nothing specific or special to answer. So answer is 1.5 volts. Now what you do? You replace this brand new cell with an exhausted cell. Exhausted cell. What reading do you expect? What reading do you expect? Then you may say, sir, is it you are killing our time? Can it be a question? So it would be 0 volt. Do you, all of you agree? Or dead zero, or maybe negligible cell? What is the range of, means you are having a DVM, good quality DVM with resolution after few digits of decimal point. So what is your estimate of negligible voltage? Attendance circuit. Attendance circuit. What is your range? Expected range? Whether normal voltage, good cell voltage 1.5. So whether with respect to negligible. So how much? It is 1.5 is negligible. किती असायला पाहिजे? As good as 0. So point. We are having multiple digits after decimal point also. Means even if we stretch by a wild imagination, one very common, now for this there is no hard marking. What is exact negligible? Because it depends upon how you are looking at it. But at least by all kinds of what we can say judgments, one means everybody, म्हणजे इथं असं काही फुटपट्टी definition नाही आहे. There is no definition of such. But a common sense, everybody of you will agree that negligible means it must be at least below. Is it right? It is agreeable to all. Is it all right? So voltage should be below 0.02, 0.03, 0.05, 0.06. But in any case, less than 0.1. Means in any case, it should be 0.0 and then something. Agreed? Is it okay? Now, will you be shocked if you can? How many of you are having personal DVM? Do you have digital voltmeter? What are you doing? Hello. Look at the whiteboard. Everybody has to look at the whiteboard. When I make you to look at the whiteboard, it is expected that you are also attentive. But whether you are attentive or not, that can be verified. But at least to be having looking at the whiteboard is a necessary condition for being attentive, which I can ensure. So if you have a DVM, you can bring a cell which is out of use, exhausted, and you can actually measure. And will you be shocked if you find that the voltage of that shown by the DVM of an exhausted cell is around, will you be shocked or not? If it is around 1.2 volts, will you be shocked? Yes or no? Shocked. Let us say that for again safer side, it is 1 volt. So an exhausted cell gives you 1 volt. A good cell gives you 1.5 volts, exhausted cell gives you 1 volt. And you are told, you are at home, your parents have told you to bring the new cell. Then innovation, what kind of, this is not innovation, but means after some time you realize. So what kind of innovation you can play with it now? That the battery was working, it stopped working, so your parents told you to bring 2 new cells. It's a 3 volt battery. So what kind of innovation you can play with, so that you can claim that you are engineering students, and you can say that, see, we were stupidly doing few things earlier, now I am an engineering student, I am having innovation, and I will have some idea which will save our money. What you will do? Good battery, for torch to work, 3 volts are needed. A good cell gives you 1.5 volts. You put 2 in series. And you will find that exhausted cell is giving you 1 volt. So what kind of innovation we would like to play? And claim that yes, and what we can shout like Eureka, like Archimedes. What we can do? You got the answer? You are talking about innovation? What? At least somebody should tell. What will you do? What kind of innovation you expect now? Simple logic. A torch requires 3 volt supply. 2 good cells were there, 1.5 volts each. Now the torch stopped working. You brought those exhausted cells and you find that no, it's not giving me 0 volts, it's giving 1 volt. So what kind of innovation you will do? Right. Use innovation that you may have 1 cylinder, just like some torch is having a cylinder. So you can bring 1 empty cylinder, construct that, put instead of 2, have 3, have proper placing, and put these 3 cells. Now the question is, will it work or no? If it works, then there are few further questions, and if it doesn't work, then the obvious question is why it doesn't work. What do you think? What do you think? If it is working, what would happen? Let us say if what he has said, innovation is working, what should happen in the scenario in the world? It's not a rocket science, it's not a patentable formula, so everybody should have known it, and such gadgets should have been there in place. So obvious answer is, it doesn't work. Then, why it doesn't work? Now, if you connect 3 exhausted cells in series, right? 2 good cells in series, A and B, and 3 exhausted cells in series. If you connect voltmeter between A and B, it will read 3 volts. Is that good? And these are exhausted. If you connect a voltmeter between A and B, it will read 3 volts. If you connect voltmeter between C and D, it will still read 3 volts. That is sure, you can perform an experiment. However, if I have a lamp, a torch, if I close switch in this case, the lamp will glow. If I close the switch in this case, the lamp will not glow. Now at least answer why.
The sensor exhausted, no current flow is there.
And but if I measure the voltage, then
Only voltage is there.
only voltage and no current. What does it mean? Anybody else? Anybody else? What is an ideal constant voltage source? I think which was the first subject in your electrical your department subject course which you put out? Fundamental electrical engineering, right? So what is an ideal constant voltage source? It always gives constant voltage across it irrespective of the load connected to it, right? But such an ideal constant voltage source cannot exist. Such an ideal constant voltage source cannot exist. Why? What is the reason? Now, if you take an example, how to understand regulated power supply, we need to understand what is unregulated power supply, what is the need of regulation. So, electric generation using electromagnetics, which is in Koina, using electricity generation using electric generators is very later phenomenon. What was the first phenomenon with which the DC electricity was generated in centuries back? Which cell? This dye cell is also that way later technology. What is the first few centuries back? Which was the, what we can say, supply for electricity? What was used to generate electricity? Means galvanic. You can give the exact name, galvanic, or rather to be its specific name, using electrochemical cells. What was the logic? Electrolyte and electrode, copper sulfate and copper, right? Listen very carefully because this is very fundamental. Copper sulfate and copper. So what is electrochemical equivalent? It is voltage, potential difference. So electrochemical equivalent is a parameter, is voltage getting developed the moment at which you put the metal in an electrolyte which is made up of the compound of that metal. लक्षात आलं? Copper sulfate, zinc chloride. So it is a potential difference between the electrode and electrolyte, and it is property of the what? Is it property of the metal or property of that compound? It is electrochemical equivalent is defined. What you are doing? You are writing electrochemical equivalent. Look here. Electrochemical equivalent is a property of what? No, not two different compounds. It's very important, I am again repeating. Electrochemical equivalent is a property of a pair. Which pair? Copper and copper sulfate. How can you generalize it? A pair of a metal and its compound. So copper sulfate is having one electrochemical equivalent. Copper chloride is having another electrochemical equivalent. Zinc sulfate. Means zinc sulfate ECE is not copper sulfate ECE. Copper sulfate ECE is not copper chloride ECE. Is it right? So electrochemical equivalent is a property of a pair, metal and compound. Then how you, so one metal you can, that is point is available. How you get the electric potential of the compound to get a potential difference? How you get the other potential? लक्षात आलं का? कॉपर रॉड एक ते टर्मिनल मिळालं आणि कॉपर सल्फेट किंवा झिंक काय असेल ते कॉपर सल्फेटचं त्या सोल्युशनचं इलेक्ट्रोलाइटचं पोटेन्शियल कसं मोजणार? Suppose if you put another copper, then what will happen? Again, there will be electrochemical equivalent. So to measure the potential of the electrolyte, you need to immerse something in that electrolyte which is having zero electrochemical equivalent between that and the solution. So you have to put what? Standard, that we need not be so much classical. Simple solution. Glass container, copper sulfate solution, copper one rod and other rod of something. Some practical, see, all the theory you understand. How you actually create it. Glass container you get, copper sulfate मोरसूद मिळतं, copper sulfate solution, copper rod, you have to measure voltage, where the other thing will connect. Other wire of EVM, a DVM, कुठं जोडणार? Of what? CuSO4, Cu rod आणि इथं काय टाकणार? SO4? असं काय? We want to measure its potential. For that, any other rod which is not of copper, right? That's all. And then you measure the voltage, that is electrochemical equivalent. Right? And one more thing is there. Electrochemical equivalent is what I said, property of the pair. And very important thing, it is independent of concentration. Most important thing, it is independent of concentration of electrolyte. Means suppose you bring the container, put water, put copper rod, put steel rod, measure voltage, it will be 0. Bring copper sulfate, मोरसूद असे खडे आणले, put it. When you put copper sulfate sufficiently, you will get some voltage. When nothing was put, you are not getting voltage. When you put copper sulfate, you will get some voltage. Now even if you go on adding copper sulfate, voltage will not change. Why? Because that is the property and it is independent of concentration. Right? Now, a very interesting thing. So such a battery cell you have. So let us say this is positive and this is negative. Right? So that battery I have got with me. Right? And I have got this. And now I have got a resistance here in variable. Right. Now I connect some resistance. What will happen? Current will flow. Right? If I reduce the resistance, what will happen? Reduced resistance will require more current flow. Current is what? Flow of charges, or to be very precise definition, rate of flow of electric charges, or to be more precise, time rate, because normally when we don't express it is depending as time rate, but we specify it explicitly. Now it is electrochemical cell. On chemical side and electrical side, it is so important that you will never forget in lifetime. Chemical and electrical side. On electrical side, it is voltage. It is proportion. It is dependent on what? It is EC, is a property. Electrochemical equivalent on chemical side is related to voltage on electrical side. Like that, current will be proportional to, connected to, related. Current is on electrical side. What is it is? Current is dq by dt, time rate. Is rate of something, rate of flow of charges. So this must be connected to something on chemical side. What something? This is rate. The current is rate of something. So on chemical side also it should be connected to a rate of something. Agreed? Rate, it is rate of some happening. It must be also some rate. Then do you recollect? Is rate to what rate? Electrolysis is not electrolysis. It is reverse process. Rate of, see, it's very simple actually. Rate of chemical reaction. He was not sure, so he was hesitating. Rate of chemical reaction. Right? When there was no resistance, no current, much reaction was not happening. When you connect resistance, there will be current flow. That will call for, so when current flows, chemical reaction will speed will increase. Then if I reduce resistance, it will demand for what? More current. So it will demand for chemical reaction to. I go on reducing the resistance. It will call for more current, it will call for more chemical reaction. Then what is the problem? I can go on reducing resistance less, it can approach zero, it will demand very heavy current. Will it work or it will not work? Why? Now, very interesting thing. This rate of chemical reaction is related to what? Rate of chemical reaction is related to ECE is property of the pair, not related to, not dependent on, not proportional to constant. It is independent of concentration. But rate of chemical reaction which can take place is proportional to concentration of electrolyte. Okay? Now what is the problem? You have ample copper sulfate, you can go on adding. What is the problem now? I think he knows everything. Somebody other than him. I listen what he said from his lip movement. Anybody else? What is the problem? If you want more current, have more concentration, which will allow that much reaction. What is the problem? Where is the problem? Means suppose that you go on writing notes. You feel that I am going to write huge. You will bring a big notebook. No, there is no problem. There is no question of notebook getting short. I hope that I am sarcastically saying it because you bring a small notebook for all the subjects. Right? So that notebook not sufficient to write the notes, this question never arises. Like that, concentration not sufficient to have chemical reaction at a rate required to give current, specified current, that will not also problem. You can bring any kind of, just you can bring a 400 page notebook. Like that you can bring 2 kg of copper sulfate. What is the problem? What is the problem? The rate of chemical reaction depends on concentration, but the concentration cannot be infinite. Why? Because there is a limit. What is that? Saturated electrolyte. So there is a maximum, listen now very carefully, there is a maximum value of concentration of electrolyte. That maximum value will put a maximum cap on the maximum value of concentration will put a cap on maximum value of chemical reaction, and that will put a cap on maximum value of current which the battery can supply. Is it right? So what ECE is a property that will give you what voltage it can supply, rather it what maximum voltage it can supply. Now we have come to that. And saturation will give you what maximum current it can give. Now suppose if that I have got a battery such that I got a battery of such electrolyte electrode combination whose electrochemical equivalent is 5 volts. I am deliberately taking a round figure. And the saturated capacity is such that it can supply maximum 50 amperes of current. Now this is, when you look at this, you think it to be ideal constant voltage source. It is not. So what I am doing, these are 2 terminals of the battery. This is a positive terminal. This is a negative terminal. So maximum it can supply 50 amperes. And it is made up of that combination whose electrochemical equivalent is 5 volts. So maximum current, when maximum current will happen? When there is a short circuit. What are you doing? Look at the white. So when you short it, what is the current value? 50 amperes. And same combination, you have got electrochemical equivalent is of 5 volts. So when you keep it open,